The biggest problem with virtual labs nobody talks about. Virtual labs can improve understanding, make learning easier, and sometimes even perform better than real laboratories. But there is one major problem people hardly talk about, and honestly, it changes the conversation completely. For the longest, we've been talking about the benefits of virtual labs, and to be fair, the advantages are real. Students understand concepts faster when they use virtual labs. Schools can save money, experiments become so much easier to access, even for schools that don't have proper laboratory equipment. So, if virtual labs are so good, why how come every school just hasn't abandoned real physics labs yet? Let's take a good look at this. The answer is simple based on hands-on experience. Because physics is not only about seeing animations and cramming formulas. Physics is also about the touching, the testing, the adjusting, and sometimes even struggling small before actually figuring these things out and how they finally work. Think of it like playing FIFA for the guys or playing Candy Crush for the ladies. It's not the same thing as actually entering an actual football pitch under heavy rain or actually playing to win a score. On PlayStation, everything feels smooth. On the gamepad, it feels smooth, but real life will actually humble you quickly. Same thing with laboratories. Watching a circuit simulation on a laptop is very different from actually trying to connect real wires, checking whether current is flowing in your ammeter or your voltmeter, and even wondering why the ball still refuses to light, even though you have corrected and connected everything according to the theory or the diagram that has been shown to you. So, as you can already tell, it's not the same thing as a real laboratory. So, at the core of the problem, real laboratories teach practical skills that simulations often skip completely. Things like handling instruments carefully, setting up experiments from the scratch, or even learning how to avoid mistakes while working under pressure. It's like learning how to prepare jollof rice by watching a YouTube video versus actually entering the kitchen yourself. Online, everything just looks easy and smooth. But once the heat actually starts, you suddenly realize that your rice has already formed. You get the pepper, you added too much. The timing actually just doesn't align. And let's look at a real example. For instance, imagine a student using the vertical caliper for the first time. In the virtual lab, the answer is right in front of them at their fingertips. But in a real lab, the student just has to know some of these technicals, like how to position the object properly, check the scale carefully, and avoid something we call zero error. And that physical discipline is also part of the learning process. Right from our own days, we have to actually memorize some of these things before actually stepping into the lab to perform experiments. So, virtual labs are designed to feel almost perfect. Measurements are clean, the results are almost predictable, and then mistakes are very easy to correct. In fact, simulations can even do things that real laboratories cannot do easily, like changing gravity instantly or repeating experiments over and over again without actually wasting materials, which actually sounds good. It's almost like using filters on Instagram. Everything just looks clean and smoother than real life actually. Let's look at another scenario. Let's say virtual pendulum experiment. Everything is literally coded, the motion stays smooth and accurate almost every time. But in the real laboratory, things are completely different. Air resistance affects the movement of that pendulum. Timing errors happen sometimes. Even the setup is slightly wrong. And so real life is not as neat as simulations. I remember in our lab then, it's either the table was like very slant and then it just sort of affects the balance of your rate of standing. Things like that just sort of even though they sound like challenges or limitations, but they also help us. And strangely enough, that kind of messiness is really important, especially in science education, because real science, like I've already said, is not always neat and straightforward. Wires can disconnect either while you're showing them, you didn't sellotape them well. Batteries can also die unexpectedly, equipment can be used somehow. Sometimes the problem is not even your calculation, the apparatus itself may actually default, which means that yes, virtual labs actually have advantages. And anybody who attended the Nigerian secondary school laboratory understands this immediately. Half of the class will be waiting for one working ammeter while another student is taping the galvanometer hoping to cooperate. Frustrating, absolutely. But that frustration also teaches us like problem solving. Just forces you as a student to like actually think like an actual science, trying to solve a real life problem, and then you start to ask yourself questions like, did I make a mistake, or maybe it's just the equipment that just trying to do and we just need to ask the right questions and how to like troubleshoot the problem and so on. So outside of simulations, there's really no mistake button, and that also teaches you another life lesson. In a real laboratory, mistakes always have consequences. So if you mishandle the equipment, for instance, something can spoil, something can break. If you connect the circuit wrong, the components can burn. I remember this one particular time I tried to connect. You make a connection, and then I was probably connecting a transmitter directly to the lab detection system that one of my head, and that creates responsibility and carefulness in a way that the simulation cannot fully cover. For example, imagine another student measuring acceleration with gravity. You may get different values, especially when you perform the experiment multiple times. Maybe because of timing mistakes, maybe when you let drop the bulb or apparatus, and then all of these things also affect or kind of improve learning, because with those mistakes it starts to learn in the process, and that's also where you learn patience, observation, and real life also teach students beyond just so all we are saying really is that there's this hidden limitation about virtual labs, that even though they are excellent for understanding physics, understanding alone is not enough. There's actually a big difference between reading driving instructions and actually entering traffic for the first time. The one can actually give you all the information and theory, the other one actually gives you experience and of course. So a student may completely understand, let's say, Ohm's law in simulation. In the virtual lab, or simply you just be dragging the resistor onto the screen, connect the battery using the flick of the switch or the mouse, and simply you just be dragging the resistor onto the screen, connect the battery using the flick of the switch or the mouse, and then connect the battery, see the voltage, current, resistance, even increase the resistance, see how the current drops, increase the voltage, see how the current rises, and then everything is responding just smoothly and perfectly. And then you think, wow, this is how science actually works. But in a real laboratory, it's not so. In a real laboratory, students will struggle to even connect a circuit together, and then the wires can, of course, not be tight enough, and the resistor color bands will be confusing. The power supply may not complete, the multimeter may start giving strange readings. As a matter of fact, we have different kinds of ammeters, voltmeters, and those readings also matter. That's a trick. So even if students can understand the theory perfectly, if they can't even do it, actually becomes a completely different challenge in a real physics lab. That's by far is a major limitation of virtual labs. All in all, still doesn't mean that virtual labs are good. It just means that virtual labs are yet to reach the stage where they can replace real physics labs. Rather, they can be used side by side with especially those who visited with virtual labs, are like the only realistic way that your students can gain experience by performing some of these experiments. But for schools that can afford at least an average science or physics laboratory, they can incorporate the virtual labs and also aid learners' understanding of these concepts better using the simulation. So the goal of all of this is not to fight virtual labs. The goal is to understand its strengths and its weaknesses, so that you as an educator or a science student or teacher can know when and how to use either virtual labs or real labs, knowing fully well that both of them are effective solutions to aiding students conceptual understanding and practical science. If you enjoyed this video, don't forget to like, subscribe,